How do we find the inverse of a function algebraically? Well, first it's important to understand what an inverse is. So our friends over here at Wikipedia are going to help us. An inverse function is a function that reverses another function. So here, this red function, the reverse of that over here is this inverse. And these things are reflections about the line y equals x. And that's important. Now, not all functions have inverse functions, but they all have inverse relations. And we'll talk about that in a little bit more in a second. But to find an inverse relation, we're just going to swap the input, our x value, and the output, y values, of the original function. So, of course, this is going to swap our domain and our range. All right, so let's see how this works. All right, so here we have two examples, and we're going to find inverse relations for them. The only steps are to swap x and y and then solve for y. So I have x equals 3y minus 5. Solve for y. X plus 5 equals 3y. So y equals, you can either write this as x plus 5 all over 3, or you can write it as x over 3 plus 5 over 3. And for our case, let's just go ahead and divide each thing by 3. All right, in our second example, let's go ahead and swap x and y. So x equals negative 64y cubed. Divide both sides by negative 64 to get y cubed by itself. To solve this, I'm going to have to take the cube root of each side. So I end up with the cube root of x divided by, I can take the cube root of negative 64, that'd be negative 4 equals y. So the only thing that I'm trying to show you is that you swap x and y. All the rest of it is just algebra skills. All right, could I find the inverse from a graph? Well, sure. Here I have a line, so I'm thinking, all right, y equals mx plus b, where m is the slope, so this has a slope. It goes up 3 over 1, so the slope is 3. And the y-intercept is 2. So now to find the inverse relation, I just say x equals 3y plus 2. X minus 2 equals 3y. X over 3 minus 2 over 3 equals y. Sometimes it's important to verify that two functions are inverses of each other. And the way that we do that is we just look at their compositions. If f of g of x is equal to g of f of x, and both of those equal x, then two functions are inverses of each other. So let's do an example of that. All right, so here I have two functions, f of x equals 3x minus 5, and g of x equals a third x plus 5 thirds. So I'm going to take f of g of x, and I'm also going to do g of f of x. All right, so I'll just do these one at a time. F of g of x would be f of 1/3 x plus 5 thirds. Plug that into the x of f. Minus 5. Let me squeeze this down a little bit. Whenever I distribute the 3, notice 3 times a third is just 1, so 1x. 3 times 5 thirds is just 5 minus 5. This is just x, which is exactly what we wanted. Okay, so here I have g of f of x, 3x minus 5. So that would be 1/3 of 3x minus 5 plus 5 thirds. I know that these fractions look not pretty, but they're actually not too bad whenever we're dealing with something like this. 1/3 of 3x, again, is just x, minus 5 thirds plus 5 thirds. We just got x. So since both of their compositions are equal to x, these are inverses of each other. And like a little side note, sometimes you'll be asked to verify that this is the inverse of f. And whenever you have this f with the little negative 1, this is read as f inverse, which just means the inverse function of some function f. All right, the last thing that we're going to talk about is the horizontal line test, and this is used to test invertibility. You see, if a function actually does have an inverse, then its inverse will be a function. And the way that we can test this is very simple. If we use the horizontal line test on an original function, we'll be able to tell if the inverse is a function. You see, just like the vertical line test, it can not touch the graph more than once whenever we draw a horizontal line. So let's try to answer the question, is the inverse of y equals 2x squared, given the domain of x is less than or equal to 0, a function? Well, the first thing that we need to do is come up with a table and draw y equals 2x squared. All right, so whenever you're building a table for x is less than or equal to 0, we only need points that go up to 0. So let's just do like -2, -1, 0. So this would be 4, 1, 0 from plugging those x's in. Plot those points. You get a graph like this, and this is just half of a quadratic. All right, so now we're going to use the horizontal line test. So just draw any horizontal line. It only hits the function one time. So the inverse is a function. But only for that given domain. If this graph would have continued over here, then the inverse would not have been a function. All right, so that's how we find an inverse algebraically. Goodbye.